Hey everybody. So I did a video where I actually showed my work as I was going through finding the particular solution using method of undetermined coefficients and everything. But then I made a mistake and I had to go back and correct everything. So I'll just walk you through briefly how this works again. Now, in the first part of the video, we had y double prime plus 25y equals x cosine of 5x. And what we did was we found the solution to the homogeneous version of that, right? That's always step one, where we let y double prime plus 25y equal to 0, right? We found the characteristic equation. We found the roots of the characteristic equation. We saw they were complex, right? So we got solutions y1 of x equals cosine of 5x and y2 of x equals sine of 5x. And so we found our general homogeneous solution. So that was all from part one of the video. And then we applied that theorem to find the form of the particular solution by looking at the different parameters m, alpha, beta, and k, and coming up with our set of associated functions. And so this is what the form of our particular solution looks like. Now our goal is to find out what A, B, C, and D need to be in order for it to actually solve this non-homogeneous equation. So we have to take derivatives, which is where I colossally failed in the first attempt at this video. But now it's working just fine. So we have the derivative is given over here. We have to use product rule. So we have derivative of x and then leave cosine of 5x alone, right? And then we have to leave x alone. We have to take the derivative of cosine of 5x. So we get minus 5x sine of 5x there. Okay, we have to do that for each one of these terms. We get a 2x cosine of 5x minus a 5x squared sine of 5x, right? And you can see I have purple here where I could make some corrections. Okay, the derivative of x sine of 5x, so that's going to be sine of 5x, right? And then we're going to have plus a 5x cosine of 5x, right? And then over here, we're going to have a 2x sine of 5x. And then we're going to have a plus a 5x squared cosine of 5x, like so. Okay. So that's when you take the derivative, you have to use the product rule. Now I want to regroup everything in a way that's going to be convenient for me later. Basically, grouping things on their powers of x. So if you just have a cosine of 5x by itself, right? Well, there's only one term with just cosine of 5x by itself, so there's a cosine of 5x. But then now I looked at, well, what terms have an x cosine of 5x, right? So I see that I have one term right here, so I'm going to have a 5 times c, but I have another term over here, so I have a 2 times b. So in total, we have 2b plus 5c times x cosine of 5x. Okay. And then I looked at my x squared cosine of 5x terms, and I see that I only have one of those. It's just plus 5d. Okay. Then I did my sine term. So sine of 5x, I just have c, right? X sine of 5x, I have a 2d. And then I also have a minus 5a. So negative 5a plus 2d x sine of 5x. And then sine x squared sine of 5x, I only have a minus 5b there. Okay. Now that I did that, I took the derivative again to find a second derivative. Again, having to do product rule in most of these, right? So I'm going to have a negative 5a sine of 5x, no product rule there. But then over here, my 2b plus 5c, I got to take the derivative of x cosine of 5x using the product rule. So I get that is cosine of 5x minus 5x sine of 5x. Okay. And then I have my 5d over here. Take the product rule for this thing. So it's a 2x cosine of 5x minus a 5x squared sine of 5x. Okay. For my c term over here, it's going to be plus c 5 cosine of 5x, so plus 5c cosine of 5x. Okay. Negative 5a plus 2d, take the derivative of this. I'm going to get a sine of 5x plus 5x cosine of 5x. And then my minus 5b over here, take the derivative of this. I get a 2x sine of 5x plus a 5x squared cosine of 5x. And then now, again, I regroup things based on whether what the power of x is. So my cosine of 5x terms just by itself, I group those together, right? Cosine of 5x, I had a 2b plus 5c here. But I have another cosine of 5x term here, so it's another plus 5c. So I get 2b plus 10c. My x cosine of 5x term, I have a plus a 10d here. And then I also have, let's see, somewhere around here, x cosine of 5x. Ah, here we go. So I have a minus 25a plus a 10d, and then plus another 10d, so plus 20d, x cosine of 5x. My x squared cosine of 5x term, I only have one of those, so it's just going to be a minus 25b. My sine of 5x term, well, let's see, I have a negative 5a plus 2d here, right? Let's see what other terms I have. It's just sine of 5x, another negative 5a. So then I get negative 10a plus 2d. Okay. And then my x sine of 5x term. So I have a negative 10b here. Okay. And then I also have a minus 10b minus 25c. So I get in total negative 20b minus 25c, x sine of 5x. And then I just have the 1x squared sine of 5x term, which comes from here. So negative 25d. And then now I got to plug it back into my differential equation, right? So I wrote it as x cosine of 5x equals y double prime plus 25y. So I did it backwards, but that's okay. My y double prime, I plug that in over here. My 25y is 25 times my y right there. Okay. And then now I added things together, right? My cosine of 5x term, I only have one of those, so I have 2b plus 10c, right? And that has to be equal to 0 because there's no cosine of 5x term on the left-hand side of this equation. Okay. Oh, sorry, we'll do that later. So we get 2b plus 10c cosine of 5x. For my x cosine of 5x term, I have a negative 25a plus 20d here. And I also have a plus 25a here. So this plus 25a is going to cancel off this minus 25a, and we just have a plus 20d x cosine of 5x. Okay. My x squared cosine of 5x term will have a negative 25b, but then I have a plus 25b. So I have no x squared cosine of 5x term. They're just going to cancel off, which is nice. Okay. Now I'm going to do my sine of 5x term. So I only have this negative 10a plus 2d right there. Okay. And then my x sine of 5x term. So I have a plus of 25c here, but then I have a minus 20b minus 25c. So that plus 25c is going to cancel off this minus 25c. So I just have negative 20b x sine of 5x. Okay. And then there's no x squared sine of 5x term because 25d cancels off with this minus 25d here. So these are my only four terms, and I compare it to the left-hand side, right? There's no cosine of 5x term, so I have 2b plus 10c has to be equal to 0. 20d has to be equal to 1 because those coefficients have to match. Okay. Negative 10a plus 2d is going to be equal to 0 because there's no sine of 5x term. And negative 20b is going to be equal to 0 because there's no x sine of 5x term. So some of these are really easy to solve, right? So for instance, negative 20b equals 0. That implies that b has to be equal to 0. So now plugging in that b is equal to 0, we get that 10c has to be equal to 0. So c is also equal to 0. So b and c are just gone. Okay. To get my d term, I just divide by 20. So d is equal to 1 over 20. And then now that I know that d is 1 over 20, I can plug that in here. 2 times 1 over 20 is 1/10. So then I could solve for a, just add 10a, divide by 10. So I get a is equal to 1 over 100. Okay. So when I plug that back into my form of my particular solution, remember that the coefficients went like this. A was a coefficient on x cosine of 5x, right? So that's going to be my 1 over 100 that I just found. Okay, so 1 over 100 there. My b was 0 and my c was 0, so those two terms are gone. And then my d was like 1 over 20. Yeah, so 1 over 20 x squared sine of 5x. Okay, so this is my final answer.